Hello, my name is Brian and I'm here to hack on the Tiger Beetle Rust client. Tiger Beetle is a financial database written in Zig, and it has clients in many languages: Java, JavaScript, Go, and Python, but not Rust yet. And so this project is a project to create a Rust client for Tiger Beetle, and we're doing the whole thing on stream. We're into month 3 at this point, perhaps. It's been a number of weeks now. And we are kind of in a stage where we have made a lot of progress, and we're just kind of making really rapid progress towards getting a PR in. And I'm trying to just get it all banged out so we can go get our PR reviewed. So we've already got done all of the request types, which is like the bulk of this project so far has been understanding how to implement a Tiger Beetle request, and then how to do that 8 different times for the 8 types of Tiger Beetle requests, some of which have slightly different behavior. And that's all done. And so now we're kind of been building a little to-do list, a checklist of things that we need to get done in order to put an initial PR in. And this pull request is not going to be a final production quality Rust crate, but it should be definitely good enough for people to review, and maybe even for early adopters to give it a test run and see how it works for them. Let's see. So it's still going to be a number of streams before we get there, but we're making a lot of progress rapidly. After we get that initial PR done, there's going to be still weeks of polish, performance work especially, to really get it. Oh no. All right, I just disconnected for a second, but I think I'm still going. Yeah, even though we're about to get a PR done, but there's going to be a little bit more, a lot more performance work. Right now we do a lot too many allocations at least. So, man, that disconnect really threw me for a loop. That's my first disconnect. My internet here seems to be pretty good. Today, though, I got ideas for a few things to accomplish. So we'll see how it goes. All right, I think I'm definitely probably reconnected now. Let's go get to the code and get going. All right, code's on screen. All right, like I was saying before, I have a little to-do list here at the top of our Rust crate, and we're just knocking these out as fast as we can. And I think what I want to do today is wire up the build system. So this crate, the Rust client, is actually bindings to a static library called TB client. And this library is written in Zig, and all of the Tiger Beetle clients are bindings to this library so far. I expect that will change in the future for performance reasons. But that means there's like 2 components to the build, or 2 phases to the build. We have to build like the TB client static library with Zig, and then we have to build the Rust library. But so far, I haven't connected these 2 parts of the build process together, so I want to get that done. And what I think I'm going to do is just have the Rust crate drive the Zig build. You could think of doing it the other way, but it doesn't really make a lot of sense when we think about how people are going to be using the Rust crate. They are going to be adding a dependency on the Rust crate to their Rust project, and they don't really care about what's going on in the Zig build. So ideally, Cargo is just going to make it all work. Additionally, we have to consider what's going to happen both when you're working with the local copy in the Tiger Beetle source tree, and also when downloading from crates.io. Now, I don't expect to publish this to crates.io yet, but eventually we're going to have to build this crate independent of the Tiger Beetle source tree where that TB client library lives. And so we kind of got to accommodate at least 2 different build scenarios. And yeah, I like this topic. This is a very kind of rusty topic. This is something you run into all the time with Rust projects, is how to incorporate one build system into another build system when there's FFI bindings involved, etc. And also publishing to crates.io. All right, again, let's look at the code. So first of all, let's just go rebuild the Tiger Beetle TB client library. And we're doing it by building the C client, is what the build system calls it. It means it's just a C interface for any other language to use. And that outputs the code to, or outputs the libraries to source clients C lib. Yeah, there you go. There's directories for each library. And let's go ahead and kind of get our workspace ready here. This is going to involve modifying the Rust Tiger Beetle build script, which is in build.rs. So you can see we already have a build script for doing the linkage to the TB client C library. Oh, notice there's some to-dos here that I never bothered to fill out for the Windows case. We're going to have to tackle that before we do a PR. In fact, let's go add that to our to-do list. Fix build script for Windows. Maybe we can tackle that today. Should be pretty easy. I'm going to just go commit that to do. And so we need our build script, and we're also going to need to look at the Tiger Beetle build script. And this is in build.zig. Interesting. Rust has build scripts. Zig has build scripts. Build.rs, build Zig. And I don't think, well, let's not get ahead of ourselves. I want to show you just like what this build script in Zig looks like. Let's swap windows here. Window swap. So on the left-hand side, here's the Zig build script. And it starts in this build function. That's the entry point for a Zig build script. And we don't have to look too deeply at this stuff, and I don't understand it very deeply either. But these are all like the build targets, or at least a lot of the build targets. And here are the client targets. And this client C is what we just built. And we have other targets for other clients. And I think for the most part, these don't actually build the, for example, Go client. I think they just kind of build the Zig components needed to build the Go client. Because like I was saying, like for Rust at least, the Rust build is going to be driven by cargo. And so you're not going to like cd into the Tiger Beetle build directory and run the Zig Tiger Beetle build in order to build the Rust client. So I think most of these clients, at least I think the Go client, at least, because I did look at that a little. I know I promised not to do any work off stream, but I did peek at this build script for the client, Go client. And the Go client, at least, it looks like this doesn't actually build the Go client, just kind of like preps all the Zig-based dependencies for the Go client. And so far what we've been doing is we've just been building the C client and then linking directly to that. And you can see that all these other client types have a build target for each language. But like when I think about what we need, I don't think I need to do anything special for the Rust client. I can just bind directly to the C static library. If we look at the Go client, let's go ahead and go look at clients Go and just dig a little deeper into it. Build Go client. You can see here that it's got, well, one thing these do is they output the libraries they're building, including this header. This is a C header file. It's a C header file generated by Zig code to define the API for the TB client library. And each of these language-specific build steps will output these things like this generated TB client header file to the Go specific directory. Whereas when we generate the C client, it outputs to, for example, clients/C. So that's one of the things these build steps do. But then also like the Go generator, and the reason I'm looking at the Go generator is because I was told that this is kind of like the most mature or the most similar to Rust, or at least the one that I should look at as a reference. And I don't know Go. And if we look at some of the Go code, we'll find that out that I don't actually know Go. But so you can see this generator for Go has some Go specific stuff here. It seems to be compiling Go bindings.zig, which is doing something specific for presumably CGO, the Go compiler that is allowed to link to C, as I understand it. So let's get some kind of Go specific stuff here. But so far, also, it doesn't use the GNU target, the Linux GNU target. I'm assuming because it just uses muscle for all Linuxes, but I'm not sure. The Tiger Beetle build will build for both GNU and muscle on Linux. But so far, we've been developing the Rust bindings just using the C client completely. We haven't had anything custom to do with the Zig code. And I feel like we can keep doing that. Like Rust can link to C code perfectly fine. That's what it's good at. So Go, goes a little quirky when it comes to FFI. So maybe there's special stuff that the Go bindings have to do. So I'm inclined to not even add a new build target here for Rust because we don't need it. Like we can just build the C build target from the cargo build script and then use that, use those assets or use those artifacts. The downside of doing that is that we don't have the visibility in the Tiger Beetle build system that there is a Rust client. Like here, you can like look at your build targets and be like, oh, there's a Go client, there's a .NET client. But if we don't add a new Rust thing here, we won't have that surfaced all the way up to the Tiger Beetle build system. And again, like I said before, each of these build targets will output artifacts directly to the language-specific client directory. So like the Go client build target will output everything needed by the Go bindings to the client/Go directory, whereas the C client outputs to the C directory. So if we have the Rust client depend on the Tiger Beetle C client, then the Rust client is going to have to kind of like reach around, like up the directory tree and then back into the C directory to get its artifacts that it needs to link to. But I still feel like that's fine. Like if we were going to make a client's Rust here, it would basically just be a copy paste of client C, except that the directory that it puts things in would be slightly different. So what I intend to do here is take the build script for Rust and have it like when it is in the, it'll detect like when it is in the source tree versus when it's in a cargo package. Because when it's in a cargo package, it won't come with all of Tiger Beetle. But when it detects that it's in the Tiger Beetle source tree, it'll build the C client, then like copy those C client artifacts over into the Rust client directory, and then use those. And that same process of building the C clients and then copying them into the Rust directory will prepare those static libraries for packaging for cargo. The cargo crate right now, I intend to just package all the static TB client libraries it needs, which is we can do conveniently for these TB client library, which is written in Zig because Zig is a cross compiler, an easy cross compiler. And in fact, every time you build clients.c, it builds the library for something like 6 different platforms, like all the supported platforms for Tiger Beetle. And so we're just going to put those bins directly in the crate, at least for now. The alternative when publishing to crates.io is that we would have to like go find the, or we package the Tiger Beetle source code with the Rust crate, which would kind of be an inversion of the relationship between the Rust client source code and the Tiger Beetle source code. Because right now the Rust client source code lives in the Tiger Beetle source code. And in order to like package the Tiger Beetle source code with the Rust client, you'd kind of have to like copy the Tiger Beetle source code into the Rust client source code directory. And it's just kind of a big mess. So for when we publish a Rust crate for the Tiger Beetle client, you could conceivably say, imagine like have two like configurations, two modes, where like one, it just uses a prepackaged static library, but another mode where it does the full Zig build from a Rust crate. But I suspect nobody would actually use that in practice. Some people might want it for reasons of kind of like supply chain integrity. They would want to know that they're building the TB client library, but it would make the build significantly more complicated because we have to go acquire Tiger Beetle source code. We have to go acquire a Zig compiler for whatever platform you're on. So for the initial crate that we publish, we're just going to package those binaries with the source code. Okay, enough explaining. I think I've explained well enough what the plan is here. So let's go to our build script in Rust, and let's figure out how to make Rust do the C client build for Tiger Beetle. And I just kind of need to first kind of like assess what our build script already looks like. You can see we're getting some environment variables from cargo. That's always the first step, is to figure out where we are in the world, like what target we're building for, what target we're running on maybe, and where our manifest directory is. Almost every time you write a build script, you want to first figure out where is our source code rooted, which is the cargo manifest directory. And then you can kind of like peek around the file system from that known root, the cargo manifest directory. And what I think I want to do is just kind of create a function called prepare dependencies. And that will be responsible for making sure that all these static libraries and header files are in a subdirectory of the Rust client. And then we can kind of proceed to just do the build from there. Because right now you can see here, this build script that we've got is looking, up and then into the C client code to find that library, and also to find the header file. Because we have a bindgen step here. Bindgen is the Rust program for generating Rust bindings to C code. The bindgen is also like looking up the directory tree and then back down into another directory. And so when we do our final publishing of the crate, we can't do that. The crate is kind of rooted at the crate manifest, so we can't look up to the directory structure. So we need to copy everything we need into our build tree. Hey, Cargo Moon, I'm glad to see you back again. How are you doing? Okay, so again, let's proceed with the plan. We're going to say prepare dependencies. And interestingly here, I notice that I'm not doing any error handling in the build script. This main doesn't return an error type. And these, when we get the environments, we're just kind of unwrapping. But if we're going to be moving a bunch of files around, there's always the possibility of I/O errors. So we should go ahead and make main return some kind of error type. And I think we already have the anyhow crate in our dependencies. Yeah. So easy errors, we're going to use anyhow result. And I like to type def this as any result. And then we'll say this is an any result of nil. And then all of these unwraps are going to turn into question marks. And do we have any other error handling needs here? This all, unable to generate bindings. Interesting. these all, okay, let's go ahead and do a little anyhow thing. We already have like these kind of special error messages when something fails for the bindgen step. And this will just cause a panic right now, but now that we're gonna switch to using real error handling, I kind of don't want to throw away this informative context, right? This is an error message that says specifically what we were trying to do. And right now this expect means this generate probably returns a result, and this expect says that result must be okay, must be successful. And I'm gonna try to preserve these messages while also using error handling. So from anyhow, I'm also going to import what's called the context trait. And I don't need to name the context trait, so I'm just going to rename it to nothing. This is, I don't know if it's idiomatic in Rust, but it's something I do in some situations where I have like a lot of imports and a lot of names and scopes. This is a trait. Context is a trait. And with traits generally just bring in new methods, and you often don't need to name traits. So this is going to just add a context method to Rust errors. So I'm going to just rename that context so it doesn't pollute the namespace, but I can still access the methods on the trait. And again, not sure if that's idiomatic Rust, but it's something I do sometimes. This situation, it's not really necessary. I just felt like doing it. Within this expect, I can instead call context, and this will wrap the errors generated by generate in a new error that adds this extra layer of application-specific error messaging. And then here, this is a question mark. So this is an error generated by bindgen. This is my own error added on top of that error. And when you see it displayed in the terminal, it'll list like kind of like a backtrace, 2 different errors. Like this is one error, and this error was caused by this error. And do the same thing down here. And let's just see if that builds the way I think it should. I did a syntax somewhere. No semicolon there. Unresolved import anyhow. I don't believe you. Probably this is a distinction between dependencies and build dependencies. This is a build script, so it has its own set of dependencies. Let's try that again. And okay, so this is just saying my main function didn't return a result type. I forgot to add that. So down here, we're going to say okay. All right, and there we go. And I'm just going to check mark that. Now, all we've done is just created a new error regime for this build script. Now we will say prepare dependencies, and we'll give it that manifest directory. Almost everything in the build script at some point needs to know what the manifest directory is. And then down here, we'll say fun, prepare dependencies, manifest dir is a string slice, and this again returns an any result. And just stub out that function, do a type check, and I already screwed up somehow. Cargo manifest dir. That's just an unused variable warning here. We're about to use it. All right, so if I think about preparing dependencies and look at the code we've already got, we have this header file that we need. And again, this header file is generated by the Tiger Beetle Zig build. So we have to run the Zig build before we can find that header file and copy it into our Rust client directory somewhere. And then we've also got a bunch of libraries with platform-specific names that we kind of want to avoid naming explicitly when we can, because some of these are .a files, some of these are .lib files, and that might be everything. And some of these might have like supporting files, like PDB files on Windows, things like that. But if we remember from when we were poking around before, the Zig build puts these all in a directory, and we just copy the whole directory into place. And again, the Zig is a cross compiler, so when we build these libraries, we build every single library for every platform that Tiger Beetle supports, which is very cool. Rust can't do that. It should, though. Like, the Rust should really just take Zig's linker stuff and use it. Or at least somebody in the Rust community should take Zig's linker stuff and package it up with Rust. Although there is a project called like Cargo Zig or something. There's something that'll let you use Zig as Rust linker. And eventually, maybe if that gets popular enough, it'll become an official Rust project. That's kind of how things tend to go in the Rust world. But also, I'm sorry, I'm digressing. But I think cross-compiling is just not a vital enough thing for most people that most people probably just don't care. It is very convenient when you need it, though. And with that particular project that makes Zig the Rust linker, anybody that really cares can do it pretty darn easily. And I'm actually thinking, like, would we want to use something like that in this project? But probably not. We're not a binary. We're just a library. If you're making an application in Rust, though, using Zig as the Rust linker could allow you to build all your applications from any platform. Okay, enough procrastinating. Let's remember what we were trying to do here. Okay, so the first thing I want to do is I want to detect whether this build is happening inside the Tiger Beetle source tree. Because again, we have at least two different build modes here. One is when you're in the tree, and one is when you're crate from crates.io. So I'm going to say, like, let build in tree build. Build in tree equals is build in tree. That's not amazing English. Is build in tree. Is build, yeah, I like that fine enough. And again, this is a to-do. And we'll say fun is build in tree. And again, just passing around this manifest. Is an any result of bool. And if we, probably the way to do this is to look for some anchor file up on the top level of the Zig, of the Tiger Beetle direct source that is not going to change. Probably this build script, build.zig. Like, we're going to look up and see if build.zig exists. To do that, we'll say std.fs exists. I'm kind of skeptical that that's the right function. Exists. We'll try it and see what the compiler says. Then here we're going to need to fabricate a directory. This is going to be manifest dir using Rust string interpolation. And we're going to go, our Rust manifest directory is this one here in my command bar in Emacs. So we're going to go up one directory, up another directory, 1, 2, 3, up 3 directories. 1, 2, 3, and then look for build.zig. And that is probably the whole thing right there. I don't really know if this deserves its own function now. Just like that. And then perhaps this fs exists is not the correct function, but let's run a build and see what the compiler says. I always like seeing what the compiler says, especially on stream, because oftentimes the compiler will just tell you what you did wrong, even if you just guessed the wrong function name. It can sometimes be quite surprising. Okay, we panicked at line 67. right here. So this, apparently we did guess correctly. That is the file. So now we want to say if build in tree, do one thing, otherwise do another thing. And for the not in tree case, I'm just going to completely punt. In fact, we might not need to do anything in this case. I'm going to leave a to-do here just in case, but if you think the in-tree build, what we're going to do is do the tiger beetle build and then copy all the Zig artifacts we need into the Rust client crate directory. So then if we're not in tree, the plan is to just have those exact artifacts in that exact same place. So really here we might be like, do some asserts that those files actually do exist. But again, we're not going to publish to crates.io yet, so I'm just going to put a to-do here. So if we're going to build in tree, then we need to copy stuff. Let's go refresh our minds about what needs to be copied. We need to get this header file. And again, we can look at one level up here. And in fact, I'm probably just going to go copy these paths right here. And we also need this directory right here. Let me copy that. Hey, NoCM, good to see you back in chat again. It makes me so happy that people are showing up multiple times and paying attention to what I'm doing on this project. I hope it's informative and or entertaining or relaxing. I hope maybe you get something out of it. Okay, so I need to copy some stuff. One of the things we need to copy is a directory, and one of the things we need to copy is a file. So I'm just going to give both these things I just copied names here. TB client H equals that, and TB client libs dir equals, uh-oh, I lost it in my Emacs yank buffer or whatever it's called. I'm not super savvy about how Emacs works, even though I've used Emacs for like 20 years. And this manifester is now called, this variable is called manifester, not cargo manifester. Intor says, you don't know Rust, but you enjoy the stream of consciousness talking. I really appreciate that. I really appreciate that. Thank you for saying so. You know, one of my plans for this programming streaming is just to like say everything that I'm thinking and doing, you know, the way I actually do it, not kind of hide all the mistakes and all the stupidity. Just to show people how like a very experienced Rust programmer writes Rust. You know, I'm not like a brilliant programmer. I know so many people who are just so much smarter than me. It's very humbling, but I do have a lot of experience. And I know a lot of people, I hope a lot of people can appreciate that, because like we're not all brilliant programmers, right? Most of us are just average. And so like a lot of times when you see people talking publicly, like a lot of like the big names, it's like they're so smart, but we can't all be that smart. You know, some of us are just competent. And yeah, I really want to, you know, help other people see that kind of thing. That's kind of one of my goals when it comes to like programming education. All right, anyway, I got my two things that we need to, oh, this is, my string interpolation here is all wrong. We got to format these into new strings. And the process for copying both these things is going to be slightly different. TB client is simple. We're just going to copy a file. And so I'm going to say std fs probably copy. And I'm guessing this is going to be source directory. So it's going to be TB, might as well just create variables for the destinations as well. Sorry, source destination. Let tb client h dest equals format. And again, it's going to be similar. Almost everything in your build script is going to use the manifester. It's going to be manifester. We need to think real quick about where we want these things to actually live. So here's our Rust crate directory. And we need to make some subdirectory to dump this stuff into, and then we're going to have to git ignore that directory. I think I'm going to call it a lib, manifester / lib, or native, or assets. I'm going to call it lib. And we're going to put the full path here, tb client .h, tb client.h. I think that makes sense. Although, let's look real quick at the directory structure created by the C build. cd source client C. So the C tb client build also outputs to a directory called lib. And I'm going to recursively copy that lib over to our Rust client directory. And probably I'm going to preserve this lib name here. Probably going to preserve this lib name. And that means if I call this lib, I'm probably going to end up with like a lib.lib situation, a stuttering situation. And I don't love that. I'm going to call it assets for now, but I don't love it. It's just a naming thing, though. We can always revisit. And then our libsdir, we're going to end up copying to tb client dest format manifest dir assets. And so then when we recursively copy this lib directory, we'll end up with a lib directory here. That's my plan, at least. Once we actually do that recursive copy, we'll see how well it works. The first thing we need to do is we need to make sure that this directory exists. And I think I don't remember. Nope, I'm going to guess. I'm going to guess the name of the function. I think it's stood fs make dir all. That is a recursive directory, kind of like the shell make dir -p command. And here we'll say tb client dest question mark. And let's put a to do here and just see if that builds. Make dir, here we go. So this is why I always just see what the compiler is going to say. Make dir all is not the right function, but it is called create dir all, and it figure that out. That's a good suggestion. I wonder, I don't know much about Levenstein distance, but I wonder what the distance is between those two, because that's not all that similar. It's a whole word different there. Create dir all. And then we can say stood fs copy from tb client h to tb client h dest question mark. Type check that. And I screwed up the same function call. Create dir all. Okay, that all seems like it's about right. Now we got to do the recursive directory copy. And I think we really do have to go over to the docs for this. I'm not sure if there's such a function for doing a recursive directory copy in the standard library or not. So let's go to Brave. And we go to stud.rs. I just learned of that recently. Stud.rs just redirects to the Rust standard library. And I wrote almost all this text. Fun fact that I'm not a fun fact, but I'm proud of that. I don't think I wrote this, but I wrote a lot of this text. So I wrote a lot of this text a long time ago, and I'm kind of disappointed nobody has ever come and refreshed this in a significant way. It's kind of stale. It's kind of stale. What I'm looking for, though, is the file system FS module. There's a creator all. I don't want to overlook it. Read dir, read link, read a string, remove. Okay, I think what I'm thinking of is, I thought maybe there's a chance there's a recursive copy in the standard library, but I'm probably just thinking of remove dir all, because I know like some of these recursive file system functions have a history of bugs in them, because it's a very complicated thing to write in a cross-platform way. And you can see there's like some caveats in the docs explaining things that have been discovered over time about how these are kind of weird functions. But I'm not seeing anything here that looks like a recursive directory copy. So what we're going to do then is go to the walkdir crate. This is a very important Rust crate, so important that it is, if we created a extended Rust standard library, this would be in it. So this will allow us to like walk a directory. I'm kind of wondering though, like if there's some other crate for just recursive directory copies, because this is much more general than just copying a directory. And there seems like there should be an easier way to just copy a whole directory. Let's really quick look in here and see if there's some kind of like helper function. Nah, this is just for walking directories. Let's go to ChatGPT, and we can do walkdir if we have to, but in Rust, is there a convenient way to recursively copy a directory? Yes, you can use stdfs, but it doesn't provide a... What kind of an answer is that? Yes, you can use stdfs, but it doesn't do anything. Yeah, okay, it's just saying to use the walkdir crate. Yeah. This is exactly what I was thinking we would do. I'm going to copy this. I'm just going to copy this function and see if it works. ChatGPT is pretty good at writing Rust code. Not amazing, but pretty good. I've never actually just copied code directly from ChatGPT before, but this is pretty boilerplate stuff. I'm not too worried about it. But we need to add the walkdir dependency. Cargo add walkdir. And we needed to add it to the build dependencies, but I did not pass the right flags. Walkdir goes down here to build dependencies. I don't use ChatGPT for coding that much. I mean, I almost never use it for writing code. I use it for like answering questions about like what APIs are available and stuff like that. Not because I don't agree with like doing it. I'm just not very sophisticated, and I'm also stuck in Emacs. I'm stuck in Emacs. I can't get out of Emacs, so I don't have access to like the clever Copilot stuff. So we need to import walkdir, and I've used FS so many times that I might as well import. Sorry, like I mentioned yesterday, I have a overgrown mustache right now, so I'm really itching my nose. I gotta get a haircut. Std fs. And this IO result I don't like. We're using any results everywhere. I'm going to say use std fs, and then use walkdir. And I'm going to read this code and make sure it does what I think it's doing. So the way we use walkdir is we create a walkdir in the source directory, and then it gives us a result of entry. So this is going to be either an OK entry or an error entry. And this question mark removes the resultiness of the entry. this relative path, strip prefix source. Oh, that's nice. That's correct. So these entries are all, I don't remember if these are absolute paths or relative paths, but this is going to take the relative path. Okay, they must be absolute paths. This creates the relative path to the top level. And then our target path, we're joining our I see you, Speckiest. Thank you, Speckiest. I'm going to do that. I do that at least once per stream. Sometimes I do it 4 times per stream. But again, okay, I just copied the directory. I copied the code from ChatGPT. I changed this. I changed the IO result they were using to an any result because we're using this more general any result for all of our result types. And then I did a little cleanup and imported FS, and I imported the walkdir type. And I'm reading this code to understand it and make sure it does what I think it does, also to just explain it. So we create a walkdir in our top level directory. These entries are either files or directories in that directory, but this is a result type here because you could have an IO error, so you have to use a question mark to remove the result. And then this takes the relative path. So this is the file name, well, the file name and the directories from the root of our recursive copy, and then joins the destination root to that relative path. So we're copying from the relative path to the target path. And then this is interesting. I wouldn't have done this, but this is very smart. So we have to make sure all the directories exist during our recursive copy. So we have to call create dir all again to just make sure the entire path to the files we're copying exists. But this is only doing it if we see a directory. If we see a directory, make sure it exists. What I would have done probably is just always call this, which would result in a lot of duplicate attempts to create directories recursively. So this looks great. Let's see if it type checks. Let's see if ChatGPT got it entirely correct or not. Well, that's not ChatGPT's fault. I need to import that path type. It's going to be path : path. And yeah, builds. Of course, you would expect an LLM to get this correct because this code probably exists 1,000 times on GitHub. This is the kind of function you expect to just exist in the standard library or something like that. Some common place. Like, why should I have to rewrite this? So now we need to call that. And we have libsdir. We're copying that. I'm wondering if I want to copy the libdir or the parent of the libdir. Anyway, I'll start with what I've already written here. Let's say copy dir recursive from tb client libsdir to tb client dest. And this is walkdir. So I think it's going to start looking inside the lib directory. And really what I want to copy is to this. That's my belief. But I need to create that. libdest, hdest. Sorry, just thinking a little bit about how I want to organize this code. Here's what I think I want to do. This is what I think I want to do. We'll just see what it does, actually. I'm not going to think too hard about it. This is the libsdir to tb client libsdest. Need to pluralize that. dest, and this is a reference to a string. That's a question mark there. And we'll throw another to do here. And see if this checks. Expected a path, and we have strings. I don't want to create paths. We're actually going to change these arguments to be strings, and it should still just work. This walkdir constructor is almost certainly generic over anything that looks pathish. And I don't really need to create an intermediate path type out of these strings. Join, not, okay, I do need a path to do this join operation. I'll show that again real quick. The copy dir recursive uses path-specific methods to create new paths. So I'll just go ahead and backtrack on what I just said and make both of these paths. I don't like working with paths in Rust because the APIs are a little awkward, kind of because of fundamental reasons around operating system specific character encodings. Like paths mostly deal with OS strings, as they're called in Rust. And generally in Rust code, we're dealing with UTF-8 strings. And anytime you're dealing with OS strings, it's just, I kind of got to just go look and read the docs and remember how to do the conversions I need. But this is going to be, instead of this, it'll be a path. We can try putting a from here. When in doubt, when you're doing a conversion in Rust, you can just type in either from or into and cross your fingers and hope for the best. I'm kind of skeptical this is going to be the right thing in this situation, though. Yeah, from's not implemented. Let's go read the docs, y'all. All right, this time, when we come back from the browser, I'm going to remember that I need to switch scenes back to code. And go back to std.rs and search for path. And collapse the summary and just look at type signatures. Oh, it's new. Interesting. That's also a good guess. All right, I'm going to go back to the code and say new here. And I don't need these ampersands because new creates a reference to a path. New. Let's see if that compiles. Nah, it didn't. Why didn't that work? Oh, okay. This needs to be a reference now. So the path constructor creates a reference to a path from a reference to a string or a string slice. And it's very strange that it just kind of fabricates a reference to path out of thin air. The path API is kind of strange. And path is an unsized type in Rust, which are not very common for like user-defined types. So you can't actually have a by value path. You can only have by reference paths or by pointer paths. Okay, that builds. And still we have a to-do here, but I don't think there's anything else we actually needed to do. I think if all this works, which it might not work, then we will have everything in place. So actually, I do want to leave that to-do here. And I want to go like inspect what our file system actually looks like after we have run this. Cargo run. Okay, so it panicked, but it should have run our file system code. And you can see we have an assets directory now. And I'm using the lsd command. This is a Rust-specific ls that is mostly just prettier, but on this machine it's not pretty because I don't have the right terminal fonts installed. Anyway, assets. There's our header file and our library. Worked the first try. That's great. So one thing we still have to do is we have to update our build script because our old paths are still being used by the rest of the code. And this might mean that I want to actually extract some of these paths somewhere else. I don't know. For now, I'm just going to modify them manually. But here we're going to say manifestor/assets. And now the rest of the build script can just look within the crate's own directory. And this should all work. So now I have a little bit of duplication in the names of these directories, but I'm not too concerned about it. Like if they break, things will just stop working pretty fast. Let's go ahead and do a build. Cargo build. Okay, now that assets directory, we don't want to check that in. So we already have a git ignore here. And we're already ignoring this generated Rust code. So we'll also ignore this assets directory. And when we do the final publish, there's a little bit of a juggling we're going to have to do here ultimately. For that assets directory, we don't want to check it into Tiger Beetle, but we do want to publish it to crates.io. And we might run into a situation where Cargo won't try to publish that assets directory because we've git ignored it. I'm not entirely sure. Cargo will also refuse to publish things that are not checked into Git. At least by default, you can override that. So when it comes time to publish this crate, we might run into some complications around this arrangement. All right, I'm just going to checkpoint my work now. This all seems to work. I'm going to remove these assets. There's one more thing we have to do, but first I'm just going to do a fresh build. Cargo clean. I'm going to say cargo check and cargo build. I almost always, if I'm doing a fresh build in Rust, I almost do both cargo check and cargo build because most of the Rust workflow is running cargo check and then occasionally running cargo build, but I always want my workspace primed to do both. So a fresh build, I'm going to do cargo check and cargo build. Seems to build. I'm going to run it to, I'm not running the server, so it's going to, just want to make sure it seems to work. There's one more thing we need to do in this build script though. So now at this point, essentially all of Tiger Beetle is a dependency of this crate. And to really make this build script airtight, we need to communicate a little bit more to Cargo about how to rebuild when Tiger Beetle changes. And this is going to be a little ugly because I don't really know what I'm doing here, but we needed to emit things like this. And I want to do this right, so we're going to go ahead and do it, but this is going to be a little gross. Basically what we're going to do, we're going to use walkdir again. We're going to go, we're going to go all the way up to the not the manifest directory, but the Tiger Beetle root directory. And if we are at built-in tree, so we're probably going to do this down here. But if we're building in tree, we're going to tell Cargo that every Zig file in the Tiger Beetle tree is a dependency of the Rust crate. Approximately, that's correct. That'll probably cover us pretty well. And then we can go test that by modifying some Zig code. And at that point, we won't have to ever run the Zig build again when working on the Rust crate. All right, so let's try to do that. I'm going to create another function for this called emit Tiger Beetle rerun if changed. I'm going to again pass the manifest directory. And that's going to return a possible error. Create another function approximately top down. emit tiger beetle rerun if changed manifest dir. Do I already have the tiger beetle directory up here? No. Okay. I'll just recreate the path to the tiger beetle directory in this function. This is a stir. This could return another error. Stub out that method and go look for, copy the syntax to this thing. And I'm thinking about this. If we're building from source, we don't actually care about doing this, because if the source changes, we're going to rebuild this. So this is not actually going to make, this is not going to make any sense under the new build script. And that also means we're not going to need to care about this to-do that I mentioned earlier on Windows. Because there's not going to be any situation where somebody externally to the Rust build makes a new version of this binary appear. Even if they do run like Zig build client C, that outputs this library to a different directory, not in the Rust client directory. So this whole case is not going to exist anymore. Is that correct? I think that's correct. Link search, those all still matter. Client.h path, that all looks like it matters still. Same thing for this, like we don't have to do a rerun of change on that tb client.h, although it looks like I never actually had that in place. Bindings path, okay. All right, I think what we need to do then is come down here to our, just putting this here so I can cross-reference it. This is the thing we need to omit, and we need to omit it for every single Zig file. As far as I know, I don't think there's a glob syntax for rerun if changed in cargo. And again, you can just use this walkthrough thing. But we need to come up with our, all right, let's not get ahead of ourselves here. Let tiger beetle root equals something. Manifest dir 1, 2, 3. Seems like it. And then we're gonna say, for entry in walkdir new tiger beetle root do stuff. And at the end, we're going to have to return OK. Again, we need to get rid of this resultiness. And when do we need to emit one of these? If the extension is .zig, I think we got to go look at the docs again, because I don't know exactly what methods on path are going to give us that information. All right, switching back to the browser, remember that we need to switch away from the browser again. All right, here's path. It's going to be something here about extensions. Stem, no, I don't think extension. Let's see if this includes the dot. Extracts the extension without the dot. Okay, you can see this is an OS stir, so comparing it to something is going to be a pain in the butt probably. Although right here, there's a comparison directly to a UTF-8 string. We'll see what happens. Extension is the thing we need. Oh, it's because they unwrapped it. All right, we'll see. This is going to be, it's going to make sense. Let's go back to the code. Extension, that's the name of our method. And let's say if let sum ext equals entry.extension. Now this is a OS stir, and we can compare this to a string. The problem we would have run into is if we tried to compare extension directly, like you might want to say, here's what you want to do. Here's what I often want to do with paths. I want to say if extension equals some .zig. But this is not going to work because this is a sum of OSter and this is a sum of uster. And Rust is not that magic to make that happen. But we can just destructure this option. If let sum extension equals that, and then we have to do another comparison here. If ext equals zig, now we print something. Print line, cargo rerun if changed, none of that. Probably just splat ext into that, but I'm not entirely sure because again, ext is ext is not what we want. We want the path of the entry. Right, so this is going to be instead something like entry dot path. Let's see if that works. And again, okay, even if this works, there's still the question of whether this is actually reaching into all these branches. So we're going to have to do a little debugging to make sure that's true. Let's do a cargo check and oops, L cargo check. L cargo here is just an alias I have to run cargo through less with colors. No, method named extension. Oh, I got it. Extension is a method on path, and what we have here is a walkdir entry. So we have to say entry dot, hopefully path dot extension. Seems to be correct. Path doesn't implement display. So here, again, paths are OS strings, and OS strings don't losslessly convert to UTF strings in all cases. So path doesn't just work for printing to a string, but we can say call display. I think there's a display method and get something displayable for a path, though it might be lossy. Yeah, there we go. And now we don't anymore care about the Unixiness or the Windowsiness because we're not emitting platform-specific library names. So we can just drop both of those. And what I want to do is I want to tell Cargo to let us see all of this stuff to verify that this is actually doing something. I don't remember how to do that offhand. Let's see, cargo check. Maybe verbose? Maybe very verbose, -VB. Say cargo clean, cargo check, -VB. Oh, that's a lot of stuff. Right now it's just building dependencies, but eventually go through our build script. Ah, that looked like what we were looking for. Yep. You can see here it's building Tiger Beetle 0.1. Let's just see everything that it's printing. Making sure I'm on my OBS scene, my coding OBS scene. Oh, this is a lot of stuff. This is a lot of stuff. Okay, here we go. This step is where it is. Let's see, let's make sure this is true. This is building a build script here for Tiger Beetle. Yep. You see all these environment variables that it's passing to our build script. And we emitted rerun if change for a bunch of Zig stuff. We should have omitted some other things too. Okay, the first thing we do is do the prepare dependencies. And then down here, we should expect to see these rustc link directives as well. So this all looks sensible. I see a lot of Zig stuff. A lot of Zig stuff. Oh, this does not look sensible. Okay. I don't think we want to do anything with this .zig cache. Interesting. I expected walkdir to ignore dot files when I did a directory traversal. And .zig cache is where the Zig compiler stores all of its intermediate stuff that humans don't need to look at generally. So we got to get Walkder to ignore this. Hopefully we don't have to manually specifically ignore Zig cache. We're also putting a dependency on the Zig compiler here, or at least compiler RT. Tiger Beetle bundles the Zig standard library itself, I think. Maybe all of the Zig compiler. I'm not entirely sure, actually. Yeah, this .zig cache we don't want to deal with. And probably it makes sense to have the dependency on all these Zig compiler files. But Zig cache we got to get rid of. Let's make sure we see the other directives that we wanted. Here's link search for Linux GNU. And the name of the static library is right there. So this, we covered this in the very first stream of this project. But this tells Cargo, like, when you look for native directories or native libraries, this is one of the directories you should search in. And this tells Cargo, this is the name of a native library you want to link to. And this stuff is all emitted by bindgen, almost certainly. So this is all bindgen stuff. All right, so we have a problem here still. I'm going to go ahead and look at our diff and checkpoint our work anyway, though. I'm thinking real quick before I do that. I'm thinking, let's look at this diff. I removed this code that tells Cargo to track changes for this library. I'm thinking about what that means in the crate case. In the crate case, this is never going to change. It's going to be static completely. Okay, I'm happy with that still. But something in this Walkder is not working the way I thought it would. So emit Tiger Beetle. I did believe that Walkder ignored, maybe not dot files, but git ignore. I thought it ignored git ignore. And in Tiger Beetle, it should have, it has a git ignore. And it has .zig cache in its git ignore. Maybe Walkder doesn't ignore git ignore by default. Let's go look at the Walkder. Let's go look at the Walkder docs again. This is docs.rs Walkder. There's a search for git ignore. Maybe I am thinking of some higher level crate that uses Walkder. Because if it was ignoring git ignore, you would think it would explicitly say that. Let's look at this is the Walkder struct, which has more docs. Contents first is true. Okay, that doesn't seem interesting. I'm wondering if there's like a configuration option on here that allows us to control. Doesn't look like there is. Looks like you just create it and it does what it does. I must be thinking of some other library that uses Walkder. Like Walkder is by the same author as ripgrep and the regex crate. And ripgrep, even when used as a library, Some crate by Burnt Sushi, the author of Walkder and ripgrep, also does directory traversal and ignores git ignore files. It's not Walkder though, so we got to ignore that ourselves. That's frustrating. I kind of wish I would just handle git ignore. Let's ask ChatGPT real quick how to deal with git ignore files when traversing directory. Maybe it will know what I think I'm talking about. In Rust, how do I get ignore files when traversing a directory? There is an ignore crate. Walk builder. Let's check it out. Is this a hyperlink? Is this a hyperlink? No, it looks like a hyperlink. Huh. Docs.rs, ignore. I wonder if this is by Burnt Sushi. This is by Burnt Sushi. So this must be what I was thinking of. This is a directory iterator that does the get ignore thing. Okay, so we're going to use a get ignore instead of walkdir. And cargo. Let's checkpoint this though. Let's not screw up what we've already accomplished. Get commit and cargo add help. This time I want to add it directly to the build dependencies. Let's go back to the code. I remembered. Back to the code. And this time I want to remember to add it as a build dependency. So we're going to say cargo add ignore -- build. This ignore crate is good to know about. Yeah, one of the things you got to know as a Rust programmer is like what crates are what and how to find the crates you need. And this ignore crate is a fairly important crate. Not as crucial as the walkdir crate, but good to know that it exists. Okay, so we added ignore, and let's go look at the, let's go back to the docs. Let's go back to the docs. So this is going to be very similar. Very similar. Here's ignore walk. And here's the walk builder where you can do the kind of configuration that I was looking for on the walkdir crate. But probably we can just replace walkdir with walk. And I'm going to go back to walk. Remember, walk. I'm going to say use ignore walk, and then walkdir is going to be a walk. And then this copy to recursive, we can probably just replace that with walk as well. You know, if we're working inside of a source code directory, it probably makes sense to just use the ignore walk instead of walkdir directly. But let's go do the check with the -vv and see what it does this time. I was very curious what those warnings that flashed by were. Oh, okay. These are, since we were doing a very verbose build here, it showed us warnings inside of dependencies. All right, let's go up here and look at our rerun if changed again. Okay, this looks much more reasonable. Much smaller set of source code because we're not looking for the through all those cache directories. So that's lovely. And then probably we can just change this to walk and just drop the entire walkdir dependency. This has been a great practical Rust stream so far. I'm happy with how this is going. No walkdir, just ignore. And let's do a, you know, before I said I changed the build script to not rerun if changed if the libraries changed. But what if I delete those libraries like I'm about to do? Is this going to rerun if changed? Let's do a cargo check. Wait, what is this? What is this? All right. The walkdir and the walk APIs don't seem to be exactly the same. Entry.file type is dir. Interesting. So here we said entry entry.path, entry.path. The walkdir entry doesn't provide. So before, with walk, or with walkdir, file type returned a path, I think. And with the walk API, it's returning an option. So the entry may not have a file type. I don't care enough to go read the docs and understand why that's the case. I'm just going to fix it. I'm going to say map ft.isdir. What is a file type? An optional file type. And then I'm going to say .unwrap or false. You know, whenever this could return none, and it's gonna be false. Let's try that. Okay, so that checks, and assets still has all this stuff in it. Now let's delete this assets directory and see if we get a rebuild. We did get a rebuild. Why is that? So I didn't explicitly tell it to rebuild if those things changed. Maybe because this recursive rerun if changed is running after we do the copy, and this copy is copying a Zig file into our assets directory. So we really, when we do this, we don't want to descend all the way into our Rust directory. Let's see if that's the case and say, let's go remove those assets again. One of the things that I don't really love about this, it's hard to write tests for build scripts. Like this stuff, these directives being passed to cargo could just silently stop being passed correctly, and we might not ever even notice. Like if something doesn't rebuild correctly sometime in the future, someone just might shrug and be like, huh, something's wrong, and do a cargo clean and never bother to investigate, even though it works now. Hard to write tests for this stuff. All right, let's run that VV build again and see if there's like a rerun if changed for a file inside of our Rust client. So here's where we're doing that recursive descent, or recursive walkdir rerun if changed. And here's a bunch of Zig code in clients, the Go client, .NET client. I don't see it printing anything in the Rust client though. Node, HIJP. Oh, these are not in alphabetical order. That makes sense. Go C.NET. My hypothesis seems to be wrong, but I actually don't understand why. In our code, we did the recursive copy, we did the header copy, and then, oh, we copied that. We're not copying a Zig file, that's why. I'm only depending on Zig files. I'm not depending on that header file. So I don't actually understand why this is rebuilding when I delete those files. Maybe because this is changing and cargo like considers this a dependency. Rust assets TB client H. Oh, okay, here's something. BindGen is telling cargo that if the header changes, that needs to rerun. Let's try to defeat it again then and say, oh, actually, let's probably want to commit what we've accomplished here. Let's remove a single library. Let's remove our Linux library. Let's remove that. Do we rebuild? Then. Let's do it again. One more time. So this is not actually rerunning anything because this is not rerunning anything. We're deleting it. Cargo check. Delete it. Still doesn't exist. So this seems, yes, I think we need to add another rerun if changed for these libraries, which we had before, I think, and I deleted. Is that true? No, that's not true. Yes, it was that Windows thing. Okay. This is where my practice of making bad commits is going to bite me. I got to go find that code I deleted. Git diff something build.rs. This code I shouldn't have deleted. I need this. Need that code. Where did it live? It lived right here. And so now we still have this to do on Windows that we got to deal with at some point. And then let's do a check. Oh, I also deleted those variables. These two variables right here. Do that check. And now let's try to delete that library. There we go. Now the build works. It works completely and foolproofly, and there are definitely no bugs left. Okay. Let's look at our... That was our task. I think we're done, but I'm going to just step back and take a breather and gather myself. So our task here was to not write API docs. Our task was to wire the Rust build system to the Zig build system. And now the Rust build system, when in tree, does build the Zig TB client library. When it's not in tree, I believe it hits a to-do. So I think we've accomplished everything we need for that task. Yeah, all right. Wire up build system is done. CI. Fix build script for Windows. We're gonna have to do this at some point. I don't really want to go switch to a Windows environment on stream and get this working on stream and debug this on stream right now. I guess we could try. Yeah, why not? Let's see, what's our diff here? Let's commit this. Quickly, let's clean up our history just a little bit. Make sure I've got my scene correct. I'm just going to reset onto upstream and then git add all this stuff again. Just real quick, look at all this and make sure it looks correct. Let's see how many lines of code we've written actually for this project. It's not much. We're going to run Toke. Toke is the Rust line counter. This whole project that we've spent 2 months on, just 1,300 lines of code. All right, let's push this. Force push. And real quick, do a cargo clean, just kind of re-verify that everything still works. Cargo check-in, cargo build. And I'm still kind of debating whether I want to try to switch to a cargo build, whether I want to try to switch to my Windows environment here and keep going with that one Windows to do. All right, you can see my terminal. I'm running on Windows here under WSL. I'm presently in my life, in this phase of my life, I'm only running, let's switch back to me. I'm just going to chat a while. My brain is fried at this point. Presently, I only am running Windows on this streaming machine, just for ease of streaming. Also, this machine is also my music battle station. So for streaming code and streaming music and just playing music and composing music, I'm using a Windows machine because doing all that stuff on Linux, not prepared for that challenge. And I just don't know Macs. So this is a WSL machine where the coding here is WSL, Windows system, subsystem for Linux. So I do have a Windows development environment here that I have not used in a couple months at this point. And I'm just kind of deciding whether I really want to crack it open and see if it works. Good subject for a Rust stream, though. Windows development. Let's try. Let's see what happens. All right, so I think you can see the entire terminal here. This is the modern Windows 11 terminal. Yeah, and so for NoCM, for about a decade, I was running Windows originally for dog fooding purposes, just to make sure that Rust worked on Windows. And at that point, just momentum kept me on Windows for a long time. And so I got pretty used to coding under WSL. And then sometime in the last year, I finally just got sick of the Windows churn, and I switched my other machines, my laptops, where I'm usually using my laptop. I switched those to Linux, but still doing WSL for the streaming. And WSL is great, actually. You kind of don't need Linux anymore if you're willing to use Windows. WSL is pretty great, but I am kind of tired of just Windows always telling me to do stuff and trying to force me to do new things and install new software and create accounts. Like this machine finally has a Microsoft online account. Like finally they made it so painful to have a local account that this one just has an actual online account, which that was pretty frustrating when I had to bite that bullet and take that step. Okay, so what I'm going to try to do here, let's do it. Stop procrastinating. That's kind of like my mantra on this stream. Stop procrastinating. Let's open up, oh shoot. I don't do my Windows development in the Windows prompt. I do it in the Cygwin prompt. Maybe this is going to be too much of a leap to go do some Windows development on this stream. It's going to be, yeah, it's going to be too difficult to get that all set up on OBS right now. Yeah, when I do Windows, I use Cygwin. Okay, let's forget that for now. this step here. The only thing here is just one little thing, and I could write it on Linux and just not debug it and verify that it works. Windows libraries have a different name than on all the Unixes. So this print line is going to be slightly different on Windows, and I could just write it and just assume it's going to work, but I would like to verify it because, again, debugging build scripts, testing build scripts is almost impossible. So I really want to like visually verify manually that this cargo rerun if change directive works on Windows. But forget that for now. Let's keep seeing what else we can do here. All right. CI is very related to what we're doing here with the build system. I don't know if we're prepared to add CI, but I kind of want to just like look at what Tiger Beetle CI looks like because I don't know anything about it. I'm just going to see if we can understand what's required here. And CI is kind of a pain in the butt. Every project does CI slightly differently. And the way I kind of figure out how a project does CI is I just go up to the top level directory and start looking for stuff that looks CI-ish. Usually there'll be like a script directory or something like that, or a CI directory. In this case, there's a .github directory. Seems very suspicious. Also, CI best practices are constantly changing, and I'm really not up to speed. I used to be responsible for a lot of CI, and I kind of understood how to do it all, but I've really fallen behind on all the GitHub features in the last few years. But this GitHub directory looks like it's probably going to have the stuff. I don't see anything else here that looks scripty. Tiger Beetle's source directory is pretty darn clean. I really like having a few things at the top level of a source directory for the sake of not overwhelming new readers, new maintainers, and also for presentation on GitHub. Like when you open a project on GitHub and you see just a whole bunch of stuff that is just a file listing, it looks terrible. Really, you want to see like a small file listing and then a README written for humans. Oops. All right, let's look at the GitHub directory. Looks promising. CI and workflows. Docs check. Test AOF. What's AOF? I don't know. I've heard that term before in Tiger Beetle. Ahead of file. Ahead of file. Doesn't make any sense. Test AOF seems promising. What is AOF? Let's rip grep for AOF. I'm going to back up here. RGAOF. Anybody in chat know it? Is AOF a standard term of art, or is it a Tiger Beetle thing? Wow, it sure shows up a lot in Tiger Beetle. There's a whole file called AOF. Again, I'm not a Tiger Beetle expert. I'm not a Zig expert. I have been working on Tiger Beetle for almost a year now, but I can't say I'm a Tiger Beetle expert. I don't know all that much about Tiger Beetle. I only work part-time on Tiger Beetle, so it's not like I'm completely immersed in it. What is AOF? How about some doc comments up in here? Magic number. UF entry. Test AOF. This is kind of the AOF. It's just an acronym. Like it doesn't have any, it's not spelled out anywhere. It's just an acronym. The AOF. So in my mind, I hear AOF, I want to think ahead of something, like AOT, ahead of time. AOF, ahead of file. Ahead of flush, unflushed entries. Surely it's not ahead of, but it's stuck in my head. I'm going to think it's ahead of something until I find the actual definition of this acronym. All right, I'm starting to feel like this is not going to be productive, just digging through this file. Let's go back to our CI directory. The docs check and a test AOF. Is AOF so important that AOF is the entirety of CI? I think we're going to download Zig. That's like the first step of building Tiger Beetle. Config AOF recovery. Somebody's going to tell me what AOF means, and I'm going to feel pretty dumb. It Probably obvious when somebody reminds me what AOF stands for. Replicas. Benchmark specific. Is AOF a benchmark framework? This does not really look like the CI. Let's go check out that workflows directory. Here's another file called CI. That seems promising. This looks more like what I'd expect. This is a YAML file that describes all the jobs on GitHub. Smoke. There's a smoke test. So these are probably all different runners in GitHub. When you see like your PR, all the little check marks under the CI, this is probably one of those check marks. Smoke uses that Docker container. Run shell check. So shell check is just a program for tidying or linting shell scripts. That's interesting. This is probably the only shell script in the whole repo. Okay, there's one other little one there. They're not shell checking that docs check though. But we're running download, format, build, docs check. And what I really want to see is like, what does the CI look like for the client bindings? Like none of this is related to clients. Test Alpine, test Ubuntu. This is just build test. I assume that build test is the test suite for Tiger Beetle, but I assume it is not touching the append only file. Future Highway, good to see you again. Future Highway, you're always helping me. Append only file, is that what that means in this case? That is a sensible acronym. I don't know if that makes sense for an entire like concept within like an entire thing that needs to be tested, AOF. Good suggestion though. Append only file. Okay, so this is testing. This is just running the test suite on Alpine. This is probably just running on many different Ubuntus. Future Highways posting a PR. I'm already act shaving, so I'm happy to go look at your PR on web browser here. Future Highway just posted this in chat. Wait, that is not the right link. How do I copy this link out of chat? I'm not savvy at all about Twitch, actually, y'all. Still learning. AOF, wow. Thank you, Future Highway, thank you. Introduced, you're right, you are absolutely right. AOF here does stand for append only file. Brings in an append only file for recording all transactions flowing through a Tiger Beetle cluster. Early deployments of Tiger Beetle in production. Okay, so this is some kind of special thing where the database is not overwriting in place in order to not lose any data at all. So some kind of special framework here that is so complex and important that it has an entire CI kind of a workflow dedicated to it. Interesting. Well, thank you very much, Future Highway. Today I learned. All right, remember we're going to go back to the code. And I'm really kind of feeling like I am in the weeds here. What we're trying to do, let's refresh our minds about what we're trying to do here. We're just kind of trying to look for some idea of how the CI tests client bindings. And we would expect it to be pretty messy because, you know, every single language is going to have its own tool chain. Here's test AOF. And there's running that script. This is Vopper is kind of the world simulator for Tiger Beetle. So, okay, we're getting into more complicated. So the Alpine test is just running the test suite, the unit tests. Ubuntu, we're running on many different combinations. Actually, probably just these two combinations, these two images or architectures. But we're doing more here. We're running the unit test suite, building the C client sample, running the fuzz tester, a smoke fuzz tester. There's a continuous fuzz tester running somewhere else, running the Vopper. The Vopper is also kind of a simulation-based tester and can also run forever. Here it says run once. So we're just kind of like, this is just kind of like smoke tests of the fuzzer in the simulator. Test AOF is running that special append-only mode for the database that Future Highway found. Test on Windows. So in Windows, we're running the unit test suite and also making sure the C client does something. And here, okay, here's where we test the clients. So when we submit a PR, we probably also need to provide some kind of CI configuration for the Rust client. And it's probably going to be ugly. The process of updating CI, especially when you don't know what you're doing, is often just like throw stuff at GitHub until it actually works, because you can't test it locally. So here's the matrix of configurations. So we'll probably need to add, what is this? A configuration for Rust, or probably many configurations for Rust. So you can see for Java, for example, they have a different configuration for different versions of Java. And I bet all this is going to be, oh, this is not that complicated. Why is this not that complicated? Clients. So DevHub is the start of some other rule. So OS, language, and language version are all going to be relevant to these client rules. Runs on all these things. Here's if.net, if go. So each of these different languages run in a different Docker container. So we're going to have to go find some kind of Docker container. So I don't know much about what GitHub Actions are, but it's some kind of like CI dependency. It's saying like, you know, this rule that we're looking at here also depends on this thing from GitHub CI. But I don't really, like, I don't know where this comes from. I don't know if there's a Tiger Beetle thing or if it's just some standard thing for .NET or not. I would guess this is doing some special Tiger Beetle setup, but I don't know. Like this Java version, this Go version, probably these actions are created by Tiger Beetle and they know how to interpret this. So probably what I'm going to do is I'm going to submit a PR without CI support, and I'm going to say help, and somebody else is going to do it. That's kind of the nature of CI, is that there's like a team member that knows how the CI works, and they deal with it. In our case, I know Alexi Matclad knows how the CI works. Okay, so let's pop the stack a bit. Go back to our library, and I put a question mark on this. I'm going to say, no, we're not going to deal with the CI. We're going to ask for help. Build script for Windows, not going to do that now. I'm not going to do the format and clippy now. I wanted to look at the Go bindings to kind of understand what they're doing. So far, we've only kind of just used our intuition and our own tastes to develop the Rust bindings. I want to kind of like look through the Go bindings and see if they're doing anything that we haven't thought of that we might need to add to the Rust bindings. Though I feel pretty confident about our design. I'm really liking the way our API is looking. These two are the big ones. Create test harness and write some API docs. Each of these is probably going to end up being its own stream. And we don't just want to write API docs. We're going to probably want to write docs for the top level Tiger Beetle documentation, like to indicate that there is a Rust client and you can find that Rust client. Though that might not be an MVP thing. Again, we're just kind of working on the initial iteration of this program. How about for this stream, let's do these two things still. We're getting so close in the source code that I think we're at the stage where we can run format and clippy and not worry too much about it annoying us going forward. I have mixed feelings about format and clippy. I think they're necessary tools, but I often disagree with clippy in particular. And in my own projects, sometimes I turn clippy stuff off because I don't like what clippy tells me to do. But for a public project that's going to get contributors, I just do whatever clippy tells me to do. Anyway, I think we are at the stage where we can just go get those over with. So let's go to clippy is a lint for Rust, a very comprehensive set of lints. And over time, it gets more and more opinionated. So you'll update Rust and there'll be a new clippy lint that tells you to do a new thing. And it's like, really? I don't want to. Why did someone decide this thing now at this time? 10 years later, we all have to do this thing. But let's go do the clippy. Back to our Rust client directory. And chat, give me 1 second. I will be right back. Literally 1 second. Literally 1 second. I just had to moisturize my lips. I'm happy to belch on stream, but moisturizing is a bridge too far. All right, back to the code. I need to stretch a little. Oh, it's been 2 hours now. Okay. 2 hours is starting to get to the point where I run out of steam. I've never streamed more than 3 hours. All right, we're doing format and clippy. We're in the Rust directory. Our workspace is clean, so let's run cargo thumped. And I bet it did a lot. And let's review what it did. We're just going to accept whatever it tells us to do. Let's at least look. So it reorganized some imports, removed some spaces. These are probably like extra space here. Remove some long lines, converted long lines into shorter lines. This is probably just spaces over here. I'm not sure about this. Remove some long lines. This is all okay. I kind of hate this. I mean, I don't mind this, but like in a big list of things, I would kind of prefer they're all formatted the same way, even if they're long lines. Because here you have some short lines, and here you have some multi-lines. I don't love this. I bet there's a format option that you can do to make it not do this reformatting. But in this case, it's not worth adding that configuration for us. We're just going to do it. But like readability here, I think is kind of worse because it's like, why is this different than this? It's just because of line length. Yep, all makes sense. Yep, more of those long lines. Oh yeah, future highway. There is actually, so Rust format, you can, there has a configuration file, I believe, but also it obeys attributes. And you can put like an attribute on either a function or a block that says just don't even look at this whole function. You can totally do that. And I mean, I don't want to mess with Rust format unless it's like emergency, but sometimes there will be like a function that is just like the formatting really matters. And then I will tell Rust format, don't mess with this function. Yeah, Rust format skip. So you can tell Rust format not to look at a function or maybe even an expression or a block. Not worth it in this case though. That matters a lot in like table-driven development. Like if you have like a big table of stuff where like the column lines matter a lot and you really need like the spaces to have extra white space to make things line up, that really, then you want to tell format to just leave it alone. Okay, just looking through this big old diff. Right, here's our library here. Reordering imports. Reordering. Oh, this stuff doesn't need to exist anymore. Okay. Last stream, we replaced all these temporary constants for messing with flags with the bit flags macro. So we can get rid of those. We'll do that in a second. Let's bank that. And I hate this. I really hate this. So it deleted my 4 spaces. I hate that. We're going to do it. We're going to do it, but I hate this. Like, I often like to separate sections of source code based on space. Same for markdown files. Like, this stuff is all related, so I want it up here, and then this next section is all related, and I want to space it out visually. And that's what I did here. And Rust format decided, nah, you can't do that. 1 space is enough. 1 line is enough. I don't like that at all. I should just have a stream dedicated to critiquing format and Clippy. That would be soothing for me. Okay, here's reformatted this. I don't love that either, but it's fine here. That's all. Don't love that. Yeah, don't love a lot of the. I hate what is going on here. That is gnarly. I mean, you can see why I did it because it's a long line, and format is always going to avoid long lines. But that is a pretty ugly syntax right here for this closure. And it's a problem with the closure syntax generally. There's kind of no way to format a multi-line closure argument in a way that is attractive, but that's ugly. Same thing down there. This is uglier. IMO. Yeah. This makes sense. In general, I find that I like this kind of formatting for function signatures, regardless of long lines. I just like to see everything on its own line. I like to read things narrowly, not wide, though it's a matter of taste, and a lot of people disagree. There it is, removing all my spaces that I like. This is interesting. So I had derives on 2 lines, and it put them on 1 line. Okay. In my own personal projects, I kind of never run Rust format or Clippy because I don't care. But again, when you're cooperating with other developers, gotta do it. Okay, that all makes, this is a lot of stuff here. Yeah, just what is going on here even? What is even going on here? Unsafe. Oh, it put the unsafe up here. That is interesting. That's an interesting choice. So here in this closure here, I opened a block. Like a closure is a argument list plus an expression. And an expression can be a block. And I opened a block, and then I opened another unsafe block inside of it. But Rust format just decided to put an unsafe block right there, which is an interesting choice. Like in Rust, you used to be able to write unsafe right at the beginning of a function. So here is the function opening of a function in Rust on this line here. You used to be able to put unsafe right there to just mark the whole function as being implemented unsafely. And at some point, that ability to make that syntax was removed. But here on this closure, they're kind of doing the same thing and saying, yeah, the whole closure is unsafe. Rust format, that is, not they. Okay, I'm kind of bored with all this. It's making a lot of changes, and we're just going to have to accept them. Yeah, this is all harder to read, in my opinion. What's going on here? Let's just move this to another line. Okay, there you go. Even though even from the beginning, we were going to always do whatever it told us to do. I still like to kind of like look at it and rage a little inside. Hate being controlled by the machines. All right, we did that, and I said there was something else. Okay, we ran Rust format. We haven't run clippy. And when I went through that, I said there was something else we wanted to look at. Ah, right. Those constants we're no longer using. All this stuff is gone. We need to reload this buffer. Delete these constants. And let's do a check. Everything's still good. Now we need to run clippy. This is going to be the greater rage-inducing one. This is the most rage-inducing static analysis. Let's do a cargo clippy. It's all going to take time because we're going to have to think about everything it says. Okay, only 6 warnings. That's nice. Yeah, so if you'll recall from earlier in this series of streams, I put this lifetime in here very explicitly for documentation purposes so that it would be very clear that this self is captured by this future. And the lifetime elision rules say like, well, this is the default behavior. And I can't remember the default behavior for lifetime elision in Rust. I just can't. It's beyond me, right? And I remember like reading the rules here for this particular combination of methods and futures. Like impiltrate has its own modifications to the lifetime elision rules. And I will never remember them. So if I were to read this function signature without this explicit lifetime, I'm not going to remember that this self is captured in this future. And now Clippy is saying, well, you don't need to do that, but I want to do that. So we're going to tell Clippy to, shut up about this. Needless life. So I have my own configuration system for turning off Clippy lints because Clippy doesn't have a configuration file. And the Clippy docs, I'm kind of in a mood now, y'all. Clippy docs say like, well, there is a configuration system in Clippy, but it's deprecated and it's going to be removed probably. But I have my own Clippy configuration system that it's not a public project yet, but might be someday, where I kind of collect the lints that I often find myself disagreeing with. And it's like, and a lot of the stuff Clippy warns about that I disagree with is documentation related, like readability related. Like it says this in lifetime is needless, but this is documentation, right? This tells you a lot, seeing that lifetime name there, in my opinion. Yeah, so I'm going to tell Clippy, I want these lifetimes. So up at the top of our file, I'm going to say, and we'll see how this goes in review. This might not make it through PR review. Allow Clippy needless lifetimes. Yeah, if I continue streaming Rust-related topics for an extended period of time, ranting about Clippy is probably going to be a common occurrence. Oh no, here he goes again on the Clippy rant. Here's a casting raw pointers to the same type is unnecessary. Interesting. That does seem unnecessary. Let's go to line 540. Why did I do that? Let's make sure that still works. Okay. Redundant field names seems reasonable. What line is this? Oh, this is in. Oh, that's all of the warnings in our library. Great. Everything else is in main. And this main function is not going to survive to the PR because it's just junk. So who cares about all this? That was actually much easier than I expected. Clippy only had 2 complaints. I was really disparaging Clippy there, and I'm not going to apologize to Clippy, but not as bad as I expected. Let's look at our diff again. Okay. I better put a comment about why I'm doing this. .s lifetimes in request methods. Like that, tick s. And we can remove those two. The go bindings. Okay. I think it's okay. We can go like, we're really winding down now, chat, but we can kind of go poke around the go bindings and just see if there's anything interesting there to see. But we're not going to do any more hacking on this stream. The reason I want to review the go bindings is because, again, I've said this a few times today already, but we haven't really looked at the other bindings for any precedents in developing these Rust bindings. We just kind of like followed the code and used our intuition. And maybe some of the previous bindings developers have done something interesting that we should be taking into account. But it's going to be tough because I don't know Go really at all. I mean, I'm vaguely familiar with it. And I've been told the Go bindings are the ones to read. And I'm expecting we might see something like different approaches to handling request results. In particular, in our results, we've done some extra work beyond just the bindings where we kind of zip up the results with the events in order to figure out which results are for which events. That's kind of like some extra work that you might punt back to the user because the protocol doesn't like suggest that we need to do that in the bindings or in the client. Also, there might be some kind of higher level affordances that the client library gives you, make it easier to work with the API. Anyway, here's the Go. This is the directory for the Go bindings, and I'm just going to poke around here a little. I'm not really expecting to get a lot of insight. You see they have their own ci.zig file. Interesting. This Go bindings, I think this is a bindings generator. So Tiger Beetle has a lot of custom bindings generators. Probably out of necessity. Though for our Rust bindings, we just ran bindgen. Yay. And this tbclient.go, I suspect that is the entry point for the Go client. Assert, there's an assert directory here. I don't know what that's about. It's a README file I could read. Generated, it's a generated, oh wow. The README file is generated. That's something we might have to think about. Okay, well, we learned something. Apparently the clients have generated README files. I don't know how I feel about that. Let's look at this README file on the browser and see if it renders pretty. All right, let's go over. All right, we're really yak shaving here. Let's go say localhost 4000 Tiger Beetle. And we need the client source, clients, go, readme. That's not amazing right off the bat. There's this kind of metadata thing here. Probably for the purposes of generating the website. I'm guessing that all this stuff feeds into the website's documentation generator, but this won't read well on GitHub, for example. It's just going to have this random metadata stuck there. Client for Go. Prerequisites. Setup. All right, so another thing we're going to have to do is going to add a README. I'm going to just go back to the code right now and make a note of that. So we got to deal with this generated README thing in our Rust bindings too. Lib.rs make generated README. All right, switching back over and just looking at this README some more. Setup, create a, this all must be handwritten stuff. This isn't generated. So we're going to have to write something like this. Makes a lot of sense. Sample, oh, there's sample Go projects. Okay. We're not going to do that for our Rust MVP for sure. Yeah, who knows? So probably for our MVP, we'll like set up the system where it generates the Rust README, but I'm not gonna go through all this. Though this is encouraging that this is all documented in a kind of like tutorial fashion. I'm curious, I'm expecting that this entire README feeds into the website. I kind of want to go look at the website right now and just confirm that. Let's go look at the docs and client libraries. Go. I bet this is this. Yeah, this is the exact same thing. Okay. Yeah. So for an MVP, we might actually not want to do this because we're not going to want to put incomplete docs for a pre-production crate on the website, because whatever we put in this is going to feed directly to the public production website. I'm going to look at this a little closer because the whole point of looking at this Go code was to kind of understand what their API looks like. Sample projects, creating a client. Okay, so they by convention, they're using, they're suggesting TB addresses to get the addresses for Tiger Beetle. New client, this is the cluster, this is the addresses. That all looks pretty straightforward. They're deferring the close function because Go doesn't have destructors, right? Okay, that's all pretty nice. Creating accounts. So they're calling create accounts and then passing an array or a slice. There's a slice of accounts. Makes sense. It's very similar to what our REST API looks like. Account flags. So the bit field. And they're doing, they have a struct called account flags for their bit fields. I don't really know in Go what a bit field looks like, but we also created an account flags bit field struct in Rust. Response. If the response is non-empty, okay, so interesting here. The way they handled their responses is not the way I did it in the Rust client. They're just kind of passing through the underlying protocol responses. So again, in Tiger Beetle, some of the responses are empty responses, and you're kind of responsible as the client or the protocol user to figure out what it means when you get a no response. Like some of your responses might be errors, and then some might be empty, just no responses. And so we kind of decided, I decided, that was just too much of a burden to put on client users to figure out how to deal with empty responses for each different type of request, because different requests have different meaning for empty responses. And so our request methods just figure that out for the client. We do a loop when we receive responses, and we kind of do a parallel iteration over the requests and the responses and correlate them back to each other on behalf of the caller. And the Go client does not do that. So they have to explain like that behavior here. And there's a, kind of a big section explaining that, and it's just boilerplate stuff. But because we did that in the Rust API, we have an extra vector allocation because of that. And it might be able to remove that vector allocation by returning instead of a vector an iterator. So basically a stack-based state machine, instead of allocating all the responses, reallocating all the responses at once, we just kind of return an iterator and let the caller iterate through the responses and do that parallel iteration and correlation lazily if they want to. So that is optimizable. Yeah, I kind of feel good about our decision, but again, we'll see whether that makes it through pull request review. Account lookup is batched. Okay. There's just kind of a note about how to use the lookup accounts request. This creates a journal entry between, it's just an example of how to use create transfers. Yeah. Response and errors. Wait, there's another section on response and errors. So Okay, so every type of request might explain responses and errors here. So again, like the semantics of Tiger Beetle's protocol for their create accounts responses. The semantics is for create accounts and create transfers is actually the same, and they're re-explaining it. They're re-explaining the same thing here. Interesting. You batch API requests. Okay. So there's a lot of very useful client documentation in the Go README, and ultimately we'll want the Rust README to be kind of self-contained and also very useful and explanatory. So we're going to eventually have to kind of like write all of this documentation, but even better. Not for the MVP though. Yeah, for those just joining us, we're working on the Rust client implementation for the Tiger Beetle financial database. And we're almost at a point where we can submit a pull request. And I'm just kind of now reviewing the Go client to get ideas about what they're doing to compare to the Rust client. And the other clients are written by Tiger Beetle experts that know much more than me. Transfer flags, just more explanation of transfers and more explanation of flags. Okay, I get the idea. Most of this is not specific to the Go client, and I kind of feel like I understand their design philosophy and how it differs from my design philosophy when it comes to the client API. Let's go back to the code and just real quick. I just kind of want to see what the Go code looks like. We saw the Go README. This is the Go bindings. This is a bindings generator. I'm kind of curious why they needed a custom Go bindings generator, but I guess it has to do with the complexity of CGO. Something I don't know much about. Yeah, I don't want to look through this. Let's go look at the TB. So they have samples here, which is nice. We might want to do that eventually. Not MVP stuff though. Package. I don't really understand how Go package organization works, but I think this is like the main module, and this package directory is supporting code. So this TB client Go, let's see if I have a Go mode in Emacs. Go mod? That doesn't sound right. No, that is definitely not right. I'm in Go mod now. I'm in Go mod mode now. Let's see if I can undo that. Go mod. Nope, can't undo it. I'm stuck. Let's switch to fundamental mode. Just Emacs stuff. So I don't have syntax highlighting for Go installed. This, I don't know if this has meaning or not. It's in a comment, but it might be like CGO glue magic. I'm kind of learning about Go as we go right now. There's an interface for the client, so possibly they defined two clients. Maybe one is that echo client that we've seen before when developing the Rust code, and I don't know what the echo client is for. Request struct, client struct. That's okay. The client struct makes a lot of sense. That's similar to what we're doing. We don't have a mutex involved in ours, but ours, our Rust client is not sendable. Can't imagine what the request struct is for offhand. Here's their constructor called a new client. It's going to return a client, and they take the cluster ID and the address, which is exactly like what we're doing. Create a client. Allocate a C string of the addresses adjoined with a comma. Oh, okay. Wait. Yeah, okay. So in our constructor, let's open up our code again. This is something we've wondered about this entire series. So our constructor takes this addresses value as a string and just passes that directly through to the client. Because Tiger Beetle will, in multiple places, Tiger Beetle will parse out multiple addresses from one string. And I was wondering whether we should kind of like instead pass an array of IP4 structs or something like that. And the Go client does indeed take an array of strings for addresses, not an array of IP addresses, not an array of IP structs, but an array of strings. And then it just joins them together to pass them to the underlying init function. So maybe we need to do that. I'm going to put a to-do up here. Init should take array of IP header. Although we could also punt that to the PR and see if somebody presses the issue in the PR. Here we do an init and look for the status of TB client init. I thought TB client init was infallible. Oh no, right here. Okay, wow. There's a big thing we're not doing at all in the, okay. Chat, I've really forgotten a big step here. This is gonna take an entire stream to resolve. So long ago, we decided to punt on error handling, to just pass these anyhow error types back to the client. Anyhow is just kind of an existential error type. It says some error happened and here's a string describing it. But actually for a library, we need to be more precise about our error handling, and we need to tell you this is like a code or a Rust variant that explicitly describes the case, the error case that happened. Yeah, that's a bummer. So we got to switch out all these error types and do this. On the left-hand side, you can see here there's a translation step from the C error types to a Go error type. We got to do that in Rust too. So I'll make another to-do. Replace anyhow with this error. Anyhow is the Rust crate for doing simple existential errors, and this error is the Rust crate for easily defining precise errors. So we got to make that change before we do a PR. That's never going to get through review. And it has an impact on the API signatures too. So something you want to change early before people start trying to use this code. Honestly though, Chad, I'm really kind of fading here. I don't really want to dig through this Go code at the moment. Yeah. I think we got to wrap this up. Let's, what's going on here? I'm typing wrong. Let's make some commits here. What's our diff? Okay, well, that was very productive. We learned quite a lot by looking at the Go code finally after 2 months. That's my style. Just wing it, and then eventually go be more thorough. Okay, chat, we're wrapping up. So today what did we do? We set up we wired the Rust build system in with the Tiger Beetle Zig build system so that at least when you're building in the Tiger Beetle tree and you try to link to the Rust crate, it will go ahead and correctly build the TB client static library to link to. And that's the big thing we did. And then after that, I think we just kind of like looked around and did a few little cleanup things, and we read the Go code and kind of collected some more big to-dos that we have to do before the PR. So it felt like we were making a lot of progress and we were kind of almost at the point where we could PR, but not yet. We added a few more to-dos and we got that big one with the error handling that's going to take a whole stream probably. But we're getting closer. So my name is Brian. Burson on GitHub, BRSON. My socials are on my GitHub page, burson.github.io. I'm doing this whole Rust project on stream from front to back. And I don't have a schedule still, but I'm doing it pretty frequently now. And I usually announce it 10 minutes ahead of time on the Tiger Beetle Slack and on my Mastodon account. So I really appreciate everybody coming in and chatting and helping me out in chat, and especially the people who have come back and have at least tolerated the stream enough to want to see a few more. This has been a good one. We accomplished a lot today. All right. Thanks a lot, everybody. See you next time.